Welcome to this video on GPU and graphics terms. Today we'll explore graphics cards, VRAM, and rendering concepts that power the visual experiences on your computer. GPU stands for Graphics Processing Unit. It is a specialized processor designed to handle graphics rendering and parallel computations efficiently. Unlike a regular processor, a GPU focuses specifically on creating and displaying images, videos, and animations on your screen. The CPU, or Central Processing Unit, has few powerful cores optimized for sequential tasks, meaning it handles one instruction after another very quickly. In contrast, the GPU has thousands of smaller cores designed for parallel processing, allowing it to perform many calculations simultaneously. This makes GPUs ideal for graphics and other tasks that require processing large amounts of data at once. A graphics card consists of several key components. First is the GPU chip itself, which is the main processor doing all the graphics work. Second is VRAM, which is video memory storage. Third is the cooling system, made up of fans and heatsinks to keep temperatures down. And finally, power connectors that deliver the energy needed to run the card. VRAM stands for Video Random Access Memory. It is dedicated memory located on the graphics card that stores textures, frame buffers, and graphical data. VRAM provides faster access than regular system RAM for graphics operations, which is crucial for smooth performance in games and other visual applications. Graphics cards come with different amounts of VRAM depending on their performance tier. Entry-level cards typically have 4 to 6 gigabytes of VRAM, which is sufficient for basic gaming and everyday tasks. Mid-range cards offer 8 to 12 gigabytes, suitable for higher resolution gaming and content creation. High-end cards feature 16 to 24 gigabytes or more, designed for demanding workloads like 4K gaming, video editing, and 3D rendering. Rendering is the process of generating a final image from 3D models, textures, lighting, and effects. It essentially converts digital data into visual pixels that you see on your screen. Every image in a game, animation, or video goes through this rendering process. There are two main types of rendering. Real-time rendering provides instant results and is used in games and interactive applications where images must be generated on the fly as you play or interact. Pre-rendered content, on the other hand, is used for movies and high-quality visuals where the computer can take minutes or even hours to create each frame, resulting in much higher quality output. Let's cover some essential graphics terminology. Ray tracing is a realistic lighting simulation technique that traces the path of light rays to create incredibly lifelike reflections and shadows. Rasterization is the traditional method of converting 3D objects into 2D images on your screen. Frame rate refers to how many images are rendered per second, measured in FPS or frames per second. And resolution is the number of pixels in the display output, such as 1920 by 1080 or 3840 by 2160. Thank you for watching this video on GPU and graphics terms. Keep learning and exploring the fascinating world of computer graphics and technology. See you in the next video from Computer World Terminologies and Concepts.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.